Okay, let's look at the problem about ages and probabilities and finding a woman who is of the appropriate age to meet the age requirement for the internship. So part A says, suppose one woman is selected at random. What's the probability the person selected will not meet the age requirement? So not meeting the age requirement, it says she has to be 20 or older. So not meeting the age requirement would be these three numbers. Add those up, and there you have it. As before, I'll explain it, and then I'll show you a good written answer. So here's a written answer. The selected woman will not meet the age requirement if she's 17, 18, or 19 years old. Therefore, the probability that the selected woman will not meet the age requirement is the sum of those three numbers, which is 0.223. Now, the next question says, suppose a simple random sampling process is used to select 100 women. What's the probability at least 30% do not meet the age requirement for internships? And again, I like to underline these things or highlight certain things as you read, especially words like not. Okay, so this is building on the previous part. On the AP test, if you made a mistake on the previous part, but you continue to use that number on part B, you can still get full marks on part B, even if you miss something on part A. So for this question, we said at least 30%. Well, if I've sampled 100 women, at least 30% means what's the probability that the number of women who don't meet the criterion is at least 30, right? That's 30% right there. Now, what does it take to not meet the age requirement? Well, that's this 0.223 from what I had before. So there's a 0.223 chance that a random woman doesn't meet the requirement. This is a binomial problem. You either meet the requirement or you don't. We've got a fixed number of women here. The probability of success is set at 0.223, and the women are independent of each other. That's part of that randomness. So I'm going to use a binomial distribution. Now, this is going to be a CDF problem. It's a cumulative one because we have an inequality, which means I really need to turn it around and work it like this, because you'll recall that CDFs have to be less than or equal to, 29 here, because the 30th woman would put her in this category. And so this is 1 minus the binomial CDF. Let's see if I can type this in here perhaps. So we've got 1 minus the binom CDF, not CDP, CDF of NPX. That function right there will give me this answer, and I bet that's what the solution will reveal. So they used a lot of words to say that. Let X represent the number of women in the sample who don't meet the age requirement. This is binomial with that N and that P from part A. At least 30% means at least 30 of the women, because there were 100. So this 30 is 30 women. If this had been 200 women, this would have to be a 60. Okay. The binomial probability says the greater than or equal to 30 is 1 minus less than or equal to 29, which works out to be that value right here. You can put that in your calculator to get 0.9547 or 1 minus 0.9547. And there's your answer. Now, part C says this. All right, suppose a stratified random sample is used to select a sample of 30 women who don't meet the age requirement and 70 who do. Okay, so 30% of this sample does not meet the age requirement. Based on the probability on this probability distribution, is a woman who doesn't meet the age requirement more likely, less likely, or equally likely to be selected with a stratified sample as with a simple random sample? What do you think? One of the things that I think is hard about the AP test is getting through the words. So if you struggle with the words, read the problem a few times, and I bet it's not as difficult as you might think. So, what is the probability here that a woman doesn't meet the age requirement? Well, it's 30%, right? Because 30 of the women don't meet the age requirement. So when I use this this stratified sample, there's a 30% chance that the woman won't meet the age requirement. What if I use a simple random sample? What's the probability she doesn't meet the age requirement? Well, there it is, 0.223. So is she more likely or less likely with stratified? Well, she's more likely. It's 30% here. That's a bigger number than 22.3%. So check out this solution as shown in part A. The proportion of women in the population who don't meet the age requirement is 223. So with a simple random sample, I expect 22.3% not to meet it. But with a stratified sample, the actual percent who don't meet the age requirement is 30%, 30 out of the 100. Therefore, a woman who doesn't meet the age requirement here is more likely to make it in the stratified sample than that simple random sample. And there's a working of the STEM problem with age requirements.